Sponsored by War Thunder. Hey, how's it going, guys? It's Nate here. And in 1967, archaeologists discovered the remains of a very ancient shipwreck about a mile off the coast of Cyprus, near the city of Kyrenia. Thanks to the cargo it was carrying, the roughly 50-foot vessel was quickly identified as ancient Greek in origin, almost certainly a merchant ship, and likely sunk sometime around the year 294 BC. Scuba excavations of the site would last up until 1969, and were directed by the University of Pennsylvania's Michael Katzev, who carefully brought the entire vessel's remains, and all of its cargo, to the surface, for preservation and further study. Okay, so why am I telling you all this? Well, in the early 70s, Katzev brought on J. Richard Steffy to help analyze the ship material and reconstruct the vessel. They both put the wreck back together again, so to speak, and built a seaworthy 2-scale replica of it using ancient techniques. While Katzev himself was no expert on ancient ship construction, Steffy was. In fact, he would soon develop a reputation as one of the world's leading authorities on the subject. And amidst his corpus of research on the Kyrenia Wreck's remains, he documented a very interesting find. In a 1985 interim report on the construction of the Kyrenia vessel's hull, Steffy nonchalantly revealed that agave fibers were being used alongside pine resin to help bind the ship's hull to lead sheets and keep out moisture. Quote, "A thin matting of agave leaves and pitch was put on the hull. Sheets of lead were applied over this layer, some of them reaching lengths of nearly 2 meters within the preserved area." Unquote. Nearly a decade later, in his 1994 book, Wooden Shipbuilding and the Interpretation of Shipwrecks, which has become a seminal work in the field, when describing the Kyrenia Wreck, Steffy again pointed to the presence of agave fibers in the vessel's caulking. Quote, "Sheets of lead, only a millimeter thick, were applied to the hull after it had been coated with thick layers of a mixture of agave leaves and pitch. The edges of the lead sheets were overlapped and fastened with closely spaced copper tacks." Unquote. Now, the obvious problem here is that agave is a distinctly American plant, native to arid, dry regions of the New World, and is not supposed to have been present anywhere on the other 5 continents until its import by Europeans after Columbus's voyages. So, what are the plant's fibers doing in the caulking of a 2,000-year-old ancient Greek shipwreck? Well, in 2001, anthropology professor Dr. John Sorenson simply sent Steffy an email asking him this very question. And here was how Steffy responded, which Sorenson published in one of his own studies on Pre-Columbian contact. Quote, "You wouldn't believe how many people have protested that statement, but I was only repeating the identifications made by professionals in respectable laboratories. I am long retired, and have given most of my records from the 1970s to the university. I will have to contact Michael Katzev to find out the names of the biologists who identified the agave. But I remember the first samples were identified by Kew Gardens in England. A second set was later done in the US with the same results. But I can't remember which lab did it. At a conference a couple of years ago, I heard that there were similar ancient analyses, but they couldn't tell me where they were published. I have also heard that one form of agave was native to the Eastern Mediterranean. I am a ship construction specialist, not a biologist, so I can only repeat the information given to me in such cases. All I can confirm is that this stringy substance, when mixed with pine resin, makes a marvelous watertight underlayment. That was the only point I was trying to make." Unquote. What a response. Steffy not only affirmed that agave was found in the Kyrenia Wreck, appealing to 2 separate lab analyses, though the details of which he can't recall, but he goes on to insist that he's heard of similar findings being shared at conferences. If this statement had been made by almost anyone else, if it were some random undergrad or Giorgio Tsoukalos on Ancient Aliens or something, I think we could easily dismiss it without a second thought. But by 2001, Steffy was an extremely well-respected professor, and arguably, by some accounts, the world's foremost expert on ancient ship construction. So his words on the subject are much more difficult to dismiss. If agave was actually in circulation throughout the Mediterranean in the 2s and 300s BC, then it could have some pretty thrilling implications for theorists of pre-Columbian contact. So, what's the deal here? Were the ancient Greeks importing and perhaps cultivating agave received through some ancient pre-Columbian trade network? Well, frankly, no one really knows what to make of Steffy's conclusions. It's certainly possible that the 2 laboratories which identified the plants' presence could have made a mistake, and Steffy himself was unable to provide the names of the biologists involved. In his email to Sorenson, he suggested that he would reach out to Michael Katzev, the Wreck's head excavator, for more info. But by the time that email was sent, Dr. Katzev was in rather poor health, and he would pass away just a few months later, in September of 2001. So, understandably, that follow-up never came. In situations like this, I like to think of a certain quote by St. Augustine, which goes a long way. "When the facts are obscure, it is better to exercise doubt than to argue an uncertain case." Without more information on the lab analysis, or any additional evidence of agave's antiquity in the ancient Old World, I think we should interpret this report with a great degree of caution. But even so, it remains one of many fascinating, anomalous cases in archaeology that invite us to consider whether the Americas were really so isolated from the rest of the world in the days before Columbus. And it's cases just like the Kyrenia Wreck that are the subject of today's video. We're going to be exploring a number of anomalous findings in archaeology, genetics, and historical literature, which hint at something of a pre-Columbian exchange. Some of the arguments we're going to look at are more robust than others. The data concerning a Polynesian interaction with South Americans, which we'll talk about, seems particularly robust. But in other cases, I'm going to encourage that we err on the side of doubt before expressing judgment. Regardless, while the strength of each case varies, they're all incredibly fascinating, and I think you'll enjoy this fun ride. So, let's jump right into it. Timecodes are in the description. But first, a quick thank you to today's video sponsor, War Thunder, the most comprehensive vehicular combat game ever made, available now for free on PC, consoles, and mobile devices. Take command of over 2,500 tanks, planes, helicopters, and ships of 10 major nations, ranging from the biplanes and armored cars of the 1920s to the fighter jets and battle tanks of today. Every vehicle has been designed with an incredible attention to detail. Perhaps a little too much attention. I'm especially impressed with how everything has been modeled down to their individual components, and the game's damage system, and especially hitboxes, reflect this, offering a much more immersive and tactical experience than other titles. Join a worldwide community of over 70 million players in epic PvP battles today, and delve into the breathtaking experience that is War Thunder. With an unmatched wealth of high-quality content to discover, there's simply no game better suited for fans of military history. Play War Thunder now for free on PC, PlayStation, Xbox, or mobile devices using my links in the description. New players and those who haven't played in the last 6 months will receive a massive bonus pack on PC or consoles that includes multiple premium vehicles, the exclusive vehicle decorator, Eagle of Valor, 100,000 Silver Lions, and 7 days of premium account access. Available for a limited time, so don't miss it. Now, back to our regularly scheduled programming. The custard apple, or sitafal, sweet fruit, as it's sometimes called in India, is the fruit which grows on the Annona squamosa plant, a small tree or shrub which is indigenous to the tropics of the New World. The fruit is easily identifiable thanks to its incredibly unique appearance. It's usually a little smaller than an apple, though sometimes a bit bigger, with green to blue skin, and is characterized by a series of teardrop-shaped knobs which make up its skin. No other fruit is quite like it. It's sweet and kinda tastes a little like custard when consumed, hence its popular nickname. Anyway, while today the fruit is grown almost worldwide and is extremely popular in South Asia, it wasn't known to the people of the Old World, or at least shouldn't have been, until the Spanish brought it back following their early voyages to the West Indies at the end of the 1400s. The Portuguese are specifically the ones credited with introducing the crop to India at the dawn of the 1500s, when they brought it back to many of their newly established holdings on the subcontinent. Annona squamosa would ultimately prove to grow very well in the soils of India, and the locals were absolutely enthralled with the taste. And thus, the fruit and its cultivation quickly took off in India, and the rest is history. However, much to the excitement of pre-Columbian theorists, there's a growing body of evidence which suggests that the custard apple has somehow been around in India long before Christopher Columbus sailed the ocean blue in 1492. The fruit appears to be present in several examples of ancient Indian artwork, and some even more convincing evidence has been emerging in recent years. In 1873, Sir Alexander Cunningham, a former British Army officer turned archaeologist, stumbled upon the ruins of an ancient Buddhist monument, or stupa, near the village of Bharhut, on the banks of the Tamas River, right on the edges of the Gangetic Plain. Excavations of the site would begin the following year, and the ruins, which Cunningham dated to between 200 and 250 BC, featured several dozen artistic stone relief railings depicting scenes from ancient Indian and Buddhist legend, as well as scenes of everyday ancient life. The discovery and excavation of the Bharhut Stupa and its artwork was a pivotal moment in Indian archaeology, as it featured one of the earliest and best preserved examples of Buddhist artistic construction. However, there was one interesting anomaly reported by Sir Cunningham that greatly frustrated local botanists and has excited pre-Columbian theorists. The old archaeologist and many of his colleagues were convinced that some of the artwork featured around the stupa clearly depicted custard apples. In his 1879 report on the excavations of the stupa, Sir Cunningham would write the following, quote, Annona squamosa, the custard apple. My identification of this fruit amongst the Mathura sculptures has been contested on the grounds that the tree was first introduced into India by the Portuguese. I do not dispute the fact that the Portuguese brought the custard apple to India, as I am aware that the East India Company imported hundreds of grindstones into the sandstone fort of Chunar as for the purpose of illustrating the proverb about carrying coals to Newcastle. I have now traveled over a great part of India, and I have found such extensive and such widely distant tracts covered with the wild custard apple that I cannot help but suspecting the tree to be indigenous. I can now appeal to one of the Bharhut sculptures for a very exact representation of the fruit and leaves of the custard apple. In a second sculpture, a monkey is represented on a branch of a custard apple tree eating one of its fruits. On a third, a striped squirrel is also represented. End quote. So, not only did Sir Cunningham, who had spent more than 40 years traveling around India, both as a soldier and archaeologist, recognized the presence of a custard apple in the Barut Monument's artwork, but he claims to have encountered so many Annona squamosa plants growing in the wild that he speculates it must have been around on the subcontinent for a very, very long time. He thinks it's indigenous. Since the excavations at Barut all those years ago, numerous additional possible examples of the custard apple have been identified by scholars across historical Indian iconography. In their 2014 book, Sacred Plants of India, a work which explores the biology of various plants with prominent roles in Indian tradition and life, Doctors Nanditha Krishna and Amir Thallingham Murugasan recognized the custard apple in over half a dozen sculptures and reliefs predating the European discovery of the New World. We don't have time to explore all of the examples, and even if we did, the copyrights of the images I'd like to use would prevent me, but here's one I think I can get away with. Within this basalt stone relief, which is currently in the custody of the CS-MVS Museum in Mumbai, Krishna, Murugasan, and other scholars identify the custard apple in the right hand of the god Vishnu. This specific sculpture was retrieved from a temple in the state of Karnataka, and is believed to date back to somewhere between 800 and 1200 AD. Another example can be found at the Sanchi Stupa in the state of Madhya Pradesh, which is known for these beautiful ornamental sculpted gateways believed to have been built in around 100 BC. In Krishna's book, she mentions custard apples being present on these decorated gates, and I spent like a couple of hours combing the internet trying to search for images of this to no avail. Finally, I decided to hop into Google Earth Street View and just look at the monument that way, and lo and behold, there are some custard apple-looking things all over it. So, you get the idea. The custard apple, the fruit of the Annona squamosa plant, which shouldn't have made it into India until well after Columbus's voyage, seems to appear, at least occasionally enough, in Indian artwork dated to before that period. However, in fairness, iconography is far from decisive proof of anything, really, and we should always take this stuff with a grain of salt. It's entirely possible that the ancient artists responsible for creating these supposed pictures of custard apples meant to depict something else, made a mistake, or were, representing an extinct species of plant unrelated to the Annona squamosa. But alas, since the 1800s, Indian archaeologists have uncovered more than just artistic evidence of the plant's pre-Columbian presence. And this is what really excites me. Songhol is a small village in the modern-day Indian state of Punjab. Songhol is an ancient place, with a continuous history of human occupation stretching back to at least the Bronze Age, possibly prehistoric times, and suffice it to say, it's been of great interest to Indian archaeologists for as long as Indian archaeology has existed. Well, in the late 1980s, while researchers were in the process of digging up a number of deposits in the area, dating to between 200 BC and 300 AD, they found a rather impressive amount of charred plant remains. You see, plant remains normally don't preserve very well in the archaeological record. They just decompose so quickly that we don't have as many of them as you might think we would. However, when plant matter is exposed to fire, or just excessive heat and chars, its material preserves much better. And a bunch of this charred plant matter was found at these Songhol deposits. Recognizing the opportunity, the site managers decided to call in Dr. K.S. Sarawat from the Birbal Sahni Institute of Paleobotany at Lucknow to investigate and catalog whatever plant material was found. You can probably see where this is going. Over the course of 3 seasons, from 1988 to 1990, Sarawat systematically collected whatever remains he could get his hands on. There seem to have been a number of ancient accidental fires at this site, but many remains also appear to have been deliberately burned in trash piles, and perhaps even a few ritual ceremonies. Whatever the case, in January of 1999, Sarawat and his co-author, Dr. Anil K. Pokaria, decided to publish their findings in the Journal of the Uttar Pradesh State Archaeology Department. And while many of the plant remains they cataloged were totally expected, lots of wheats, cereals, weeds, etc., two particular findings were pretty explosive. Among their discoveries, Sarawat and Pokaria had identified two pieces of a Nona squamosa fruit, the custard apple. The two pieces found were small, only around 5 millimeters long, and all that was preserved was the skin, or fruit coat. Evidently, that's all that was charred and able to be preserved, but Sarawat and Pokaria had no doubt of the plant's identity. Their paper goes on to acknowledge the likely presence of the fruit in the ancient Indian artwork that we've already discussed, and the authors express support for a theory of a human pre-Columbian introduction of the plant via a yet unknown route, which must have existed no later than 300 AD. Furthermore, the other anomalous finding by the botanists were two carbonized seeds, which they believe belonged to the Mexican poppy, or Argomane mexicana, each about 1.8 millimeters long and found in a trench between 2.25 and 3.1 meters deep. The Mexican poppy is, of course, a toxic weed known for its extraordinary resilience native to the Americas, where, as its name implies, it flourishes in Mexico. Of course, its arrival to the Old World is therefore also not supposed to have occurred until Columbus's establishment of contact. Pokaria and Sarawat write, quote, "American plants on the soil of India during pre-Columbian times should be considered as being impossible to appear parallelly in diverse unconnected centra. Inevitably, man must have played an important role in the dispersal, because the possibilities of natural diffusion by sea, birds, or through the winds are negligible. The occurrence of the custard apple is in no way accidental. By which way it reached, when did it happen, and who was responsible for its introduction? The judgment is difficult to establish. These remains have led us to join a group of specialists supporting with diverse arguments the hypothesis of Asian American contacts during pre-Columbian times." End quote. What a paper. Now, as explosive as this is, I don't think that this study is without its weaknesses. For one, neither the pieces of custard apple skin nor the poppy seeds seem to have been independently dated. They were merely found in broader excavation trenches with material going all the way back to the Kushana period. So, while the remains were more than likely as old as everything else in that trench, until they're independently dated with radiocarbon dating or uranium-thorium or whatever, we can't rule out that some type of contamination or other pollution event could have brought these here, even though the authors do assure us that every precaution has been taken. They do not believe that these are the results of contamination. Furthermore, Pokaria and Sarawat's identification of the pieces of custard apple skin and the poppy seeds were entirely based on visual and mathematical observation. Essentially, they said, "Oh, look, these things look like pieces of custard apple skin. These two seeds look like Mexican poppy seeds. The dimensions align. We found custard apples and poppy seeds." Now, the co-authors are PhD-wielding paleobotanists, so their observations certainly can go a very long way, but it would have been helpful to also see some molecular or DNA analysis, which could have affirmed those expert observations. Regardless, in the context of all of the artistic depictions we've seen so far, actual archaeobotanical evidence, that is to say, actual plant matter which seems to be from the pre-Columbian period in India, is huge. and we're not even done yet. Though, there's a bit of a catch. Tokwa is an archaeological site in the state of Uttar Pradesh in northern India. It sits right on the edge of the Gangetic Plain, next to the Belon River. This site is known for a large, ancient mound, which, like what we saw at Songhul, features evidence for a very ancient human occupation. You see, certain historical cultures had a tendency to rebuild almost exactly on top of their old homes and structures whenever those structures were destroyed. And over the course of thousands of years, this creates a sort of mound, or tell, as they say in the Middle East, that is often full of rich artifacts and a whole lot of junk for archaeologists to dig up. This mound in particular, which first began excavation under the University of Allahabad in 2000, features its first evidence of human occupation as early as 2000 BC, and it was inhabited on and off again by humans up until the Indian Iron Age in around 1000 BC, when it was subsequently abandoned. The excavations were led by doctors J. D. Misra and J. N. Paul, who, among other things, found plenty of carbonized plant matter in the occupation strata, which was then sent to the Birbal Sahni Institute of Paleoscience in Lucknow for further analysis. This is, of course, the same institute which identified the custard apple remains as well as the Mexican poppy at Songhul, which we discussed earlier. Not only that, but Anil K. Pokaria, one of the co-authors on that paper we just discussed, was among the lead researchers assigned to study the Tokwa plant remains. This initially struck me as, I don't want to say odd, but it was a little bit of a yellow flag. Like, what are the chances that the same institute and one of the same guys who found the custard apple seed at Songhul is now being called in to review the plant matter at this other site in Tokwa, where, spoiler alert, he's about to identify more custard apple remains, but there's a rather innocent logic to it. The Birbal Sahni Institute of Paleosciences is sort of the premier institute for paleobiology in the state of Uttar Pradesh, where Tokwa is located. And Dr. Pokaria was, and I believe remains to be, one of the people running the paleobotany department at this institute. So there's a rationale to this coincidence. It's not really suspicious, but we should keep in mind that it's the same people working on this paper as the one we just analyzed. Anyway, as I've already kinda spoiled, Pokaria and his team of lovable doctors and undergrads identified multiple remains of Annona squamosa seeds amongst the collection of carbonized plant matter they were given to analyze. They specifically recognized a single full piece and a few broken, smaller seed pieces amongst strata belonging to Trench 8, and which was buried around 2.5 meters below surface level. Once again, Dr. Pokaria and the BSIP identified the seeds as belonging to Annona squamosa purely on an observation of their visual and mathematical characteristics. The seeds basically looked enough like Annona squamosa seeds and fit the anticipated dimensions. However, this time, the researchers went ahead and radiocarbon dated the seed matter, dating them back to over 3,200 years before present, or right around 1740 BC. Now, I can't help but be stunned by that date, 1740 BC. It's one thing to imagine the existence of a pre-Columbian trade network or even single group of travelers linking South Asia and the Americas. It's a whole nother thing if that network was in existence so long ago. By this point in history, the chariot had only just been invented, humans had no idea what iron was, and there were still mammoths running around on Wrangel Island. Regardless, this is the last, and seemingly most recent paper on this subject I could find. There doesn't seem to be a whole lot of people interested in studying the antiquity of the custard apple in India, but among those who are, a consensus is clearly emerging that it was on the continent long before the Portuguese supposedly introduced it. And I'm inclined to agree. Its presence in ancient artwork, combined with what seem to be obvious archaeobotanical examples, make it difficult to deny. Still though, even if the Annona squamosa plant has been in India since, the 1400s BC, we can't entirely rule out natural explanations just yet. Wind is weird, waves are weird, nature is weird. While it seems unlikely that the custard apple could have naturally made it to India, and, if it did, you would think we would have some evidence of it on Pacific Islands or other parts of Asia, but, weirder stuff has happened before. If we could just find an ancient custard apple at some archaeological site, maybe dating back to 100 BC or even 1400 BC, and if that apple were well preserved enough to run a proper phylogenetic analysis, that would go a huge way towards solving this mystery. Geneticists would be able to figure out exactly when that fossilized apple's family diverged from its American counterparts, and, if it turned out that split occurred like 900,000 years ago, okay, well then there you go, it was probably natural dispersion. But if instead we found out that split happened, much more recently, like 8,000 years ago, well, then that would be a little suspicious. Anyway, point is, the Annona squamosa plant seems to have been in India for a very, very long time. Some Indian paleobotanists suspect its antiquity on the subcontinent is the result of some kind of pre-Columbian human introduction, but ultimately more research is necessary to definitively solve this strange, strange riddle. With the obvious exception of the Native American presence in North America throughout the 10th century, which is now largely an accepted fact, of all the theories speculating about possible instances of pre-Columbian contact between the Old and New Worlds, the one probably taken the most seriously by modern scholars concerns a potential Polynesian interaction with Native Americans. Specifically, South Americans. Polynesian culture and civilization emerged in Oceania sometime between 500 BC and 800 AD, more on those dates later, and it's characterized by an unprecedented ability to navigate the open ocean. Making use of multi-hulled wooden ships known as outriggers, and using the stars as their guide, Polynesians rapidly spread across thousands of miles of the South Pacific Ocean, ultimately settling a network of islands concentrated in what is now known as the Polynesian Triangle, stretching from New Zealand in the west, to Hawaii in the north, and to Easter Island in the east. The sheer scale of their voyages, and just how much open ocean they were able to cover, has always lent itself to speculation that perhaps Polynesian peoples could have gone a bit further, perhaps pushing all the way to the shores of the Americas. They certainly possessed the skill and technical know-how for such a journey. The furthest east the Polynesians are confirmed to have arrived and settled is the island of Rapa Nui, or Easter Island as it's become known to Europeans, which is about 2,200 miles or 3,500 kilometers from the shores of South America. A distance which sounds incredibly intimidating, until you consider that the Polynesians had to travel over double that span to arrive at Rapa Nui in the first place. Anyway, all this is to say, it's been long understood that this old-world maritime civilization likely had it in them to reach the Americas. But did they? Well, spoiler alert, but in this section of the video, we're going to look at some pretty robust modern evidence which suggests that they did, and how exactly experts believe that contact may have played out. And towards the end, we'll even look at some evidence and suggestions that aren't as well accepted in the academic community and are more contentious, but are pretty exciting. But first, in order to best understand the themes that we're about to discuss, I think it's important that we have a rough idea of what modern scholars currently believe the Polynesian migrations looked like, and more specifically, the timeline in which they occurred. As this topic in and of itself is a bit mysterious, and the subject of a frequently shifting scholarly consensus. Of course, if you'd like to skip this part and just jump straight into the evidence of contact with the Americas, time codes are on screen now and in the description. But be warned, you may be mildly underinformed. As far as we can tell, Polynesian culture has its roots in the Austronesian expansion, when sometime likely within the 2000s BC, but maybe even a bit earlier, people from what is today Taiwan and its neighboring islands began sailing into the Philippines and later expanding all over maritime Southeast Asia, reaching what is today Brunei, Indonesia, and all the adjacent archipelagos. The Austronesians themselves, as you can probably tell, already seem to have possessed a very sophisticated maritime culture. They clearly loved sailing. It's thought that they may have already developed the double-hulled outrigger ships, and they kept specifically to the coasts and beaches of where they went. The various Polynesian languages which we would eventually see spread around the South Pacific all themselves seem to descend from some Austronesian language first spoken by these early navigators. This early Proto-Austronesian language has been somewhat reconstructed by linguists, and it's incredibly rich in naval and oceanic terminology, suggesting that stuff really mattered to its speakers. They had words for sail, hull, bow, deck, stern, for what direction drafts were coming in, and all different types of waves and ocean swells. The seas and the ships they used to navigate them characterized the Austronesian language and, likely, the livelihoods of its speakers. By the mid-1000s BC, Austronesians began arriving in a sub-region of Oceania known as Melanesia, which consists largely of New Guinea and a number of islands east of it going all the way up to Fiji. They settled much of New Guinea's northern coast and virtually all of the aforementioned eastern islands, reaching Fiji by no later than 800 BC. Now, when the Austronesians arrived here, many of these islands weren't uninhabited. Some, especially New Guinea, already had indigenous populations living there, whom the newcomers would go on to do a great deal of intermixing with. And it's here in Melanesia, during the 1st and 2nd millennium BC, with this fusion of Austronesian and Melanesian peoples, that we begin to see the emergence of a unique and almost recognizably Polynesian culture take shape. Between 1300 and 700 BC, these Proto-Polynesians, if you will, begin going as far as Tonga and Samoa as they start pushing into the remote South Pacific. But beyond this point, scholarly opinion on when the Polynesians start arriving on which islands and in what order they do so across the Pacific becomes hotly debated. Most experts are of the opinion that after reaching Tonga and Samoa, the Polynesians just kinda paused for a while, and don't begin going much further until around the 900s AD, when there's this sudden eruption of massive voyages that rapidly spread across the remote islands of the Pacific. Why these people stopped for so long when they did isn't clear, and it's debated whether or not that pause even happened. But the current hotly contested scholarly consensus dictates that the Cook Islands are reached by 900 AD, Hawaii and the Marquesas, which are smack dab in the middle of the Pacific, are settled around 1000 and 1100 AD respectively, Easter Island, or Rapa Nui, which is central to theories of pre-Columbian contact, given that it's the closest island to the Americas the Polynesians are known to have settled, is reached no later than 1200. Now, this rough chronology is, again, seriously disputed, and there are a lot of experts who think that the Polynesian expansion across the South Pacific occurred much earlier. There are some specialists in the field who will argue that Hawaii was actually settled in the 400s AD and that Easter Island was reached by 600. Our chronology is just a complete mess. The only Polynesian island where there seems to be a near universal consensus for the first human arrival is New Zealand, where scholars are comfortable with a date between 1280 and 1320. Part of the reason for there being so much uncertainty and confusion in our chronology of this island settlement is that the islands of the South Pacific are just terrible at preserving archaeological material. You know, moist, humid, tropical environments are bad enough at preserving human relics, but the fact that there's so much salt water here makes it 10 times worse. Not only that, but the waves of the ocean are constantly eroding at the very beaches and coastlines where people like to settle on. And finally, the Polynesians were building everything out of wood and vines, some of the most decomposable materials in existence. With the exception of some fun stuff on Rapa Nui, Polynesians weren't generally building with stone. They are never known to have used metal, and the islands they reached were often so scarce in clay that pottery just wasn't very fashionable. Those three things, stone, metal, and pottery, are like the most reliable ways archaeologists are able to identify human activity, and we have almost none of that in the South Pacific. So, suffice it to say, the age of expansion across the remote islands of the Polynesian Triangle may have begun sometime around 900 AD, or perhaps a bit earlier. Thus, even before we start getting into pre-Columbian contact theories, the history of the South Pacific is riddled with mysteries and unanswered questions, which will have a big impact on these theories as we get into them. But there you go. That's the very, very rough timeline, if you can call it that, for the Polynesian migrations. And now we can get into the fun part. Evidence of their contact with the Americas. One of the earliest indicators in this direction to have intrigued scholars is the presence of the sweet potato, found throughout both the Polynesian Triangle and the Americas. The sweet potato, or Ipomea batatas, is a starchy species of plant rich in carbohydrates and calories, known to be indigenous to Central and South America, where by 2500 BC, it had enjoyed widespread cultivation as a staple food crop amongst indigenous Americans. There is some debate about where exactly in the Americas the plant first emerged. Maybe it was the Caribbean or Central America or around Colombia, but there is no doubt that it is a distinctly American crop. And yet, when Europeans first began arriving on the islands of the Polynesian Triangle, they were somewhat puzzled to find that the sweet potato was something of a staple of South Pacific society as well. Captain Cook, Jacob Rahaven, and many other discoverers, I use that term a little loosely, of various Polynesian islands all noted the abundance of sweet potato cultivation on the islands they came across. From the beginning, many considered the dispersal of this plant across the Polynesian Triangle to be obvious evidence of some kind of early contact between Polynesians and Americans. Throughout the 19th and early 20th centuries, more skeptical voices in the academic community attempted to dismiss this idea, arguing that the Spanish could have brought the potato into the Pacific during some undocumented voyages in the early 1500s. An idea that was always considered kinda flimsy, just given the enormous scale of sweet potato agriculture by the time it was documented. But recent radiocarbon dates have all but dispelled this theory for good. Carbonized potato remains and micro-residue found in Polynesian archaeological contexts now regularly return dates from the 1200s and 1300s AD, well before Europeans could have possibly dispersed the crop. Furthermore, perhaps even more consequential, linguistics seems to be on the side of the contact theorists as well. The Maori of New Zealand's word for sweet potato is kumara. The same name is used by the natives of Easter Island. In Hawaii, the plant may have been called something like koala. Linguists have noted that these terms are suspiciously similar to what indigenous South American speakers of the Quechua and Aymara languages call the plant. Their terms are kumara and kumar, respectively. In his 2004 book, The Languages of the Andes, Professor of Indigenous American Linguistics, Dr. Willem F. H. Adelaar, dedicates a brief paragraph to exploring the similar names Polynesians and Americans gave the sweet potato. And he goes so far as to suggest that they constitute near proof of some sort of incidental contact between South Pacific Islanders and Amerindians. Though the professor emphasizes that he believes this contact to have been incidental rather than regular and frequent. Thus, today, in the modern era, the scholarly consensus has largely coalesced around the idea that the sweet potato was introduced into the Pacific through some yet unknown contact event between Polynesians and, likely, native South Americans. Now, I should stress that just because a consensus has emerged doesn't mean that there isn't some serious disagreement. There are still a minority of experts who favor a model for the natural dispersion of the sweet potato into the Pacific Islands, i.e., the plant just kinda floated across the Pacific, or its vines or seeds were carried by birds. This might sound pretty unlikely and unintuitive, but it's not at all unreasonable. In 2018, a team of researchers ran a genetic analysis on a sweet potato specimen that was collected and preserved during one of Captain Cook's first voyages to Hawaii in the 1770s. Their investigation of the plant's genome concluded that the specimen likely diverged from its closest relatives in the Americas over 115,000 years ago, likely well before humans could have been responsible for its dispersal. Their findings were published in the Journal of Current Biology. Additionally, through my own rigorous research, I have discovered that sweet potatoes float in salt water. The Nobel Laureate Committee can keep its prizes, but I think the genetic evidence, combined with the fact that the potato, floats, really does validate the possibility of natural dispersal, even if the linguistic evidence is just too solid to ignore. So, there's a healthy debate going on regarding the antiquity of the sweet potato in the Pacific, and what it all might mean. But, lucky for us, recent decades have seen the emergence of some much more robust evidence for a contact event between these two peoples. And frankly, this newer stuff just blows potato speculation out of the water. Enter human genetics. In 1971, immunology researchers working under the direction of the 5th International Histocompatibility Workshop visited Easter Island and collected blood samples from 69 individuals who were believed to be native to the island. Originally, this study had little to do with investigating Amerindian contact. What the researchers were really interested in was analyzing a set of genes known as human leukocyte antigens, which play a big role in regulating human immune systems, and are often a major barrier when trying to connect people who need organ, blood, and tissue transplants with donors. For example, say you need a new kidney. Not only do you need to find someone willing to give you one of theirs, but that donor needs to have the right human leukocyte antigens for your immune system to recognize and accept this new kidney as friendly and not attack it. The science behind this is called histocompatibility, and it's what the researchers were really trying to learn about when they collected samples from Easter Islanders in 1971. Long story short, while some interesting and important things were learned, initial analysis didn't return any results that suggested pre-Columbian contact with the Americas or anything of that nature. Though that's also not really what anybody was looking for. However, after analysis had concluded, the blood samples were frozen to be preserved for future research. Well, in 2006, more than 35 years later, a group of biologists mostly specializing in medicine and immunology decided to unfreeze many of these 1971 samples and examine them with more modern techniques. This time, specifically looking for evidence of contact with the Americas in their Polynesian gene samples. And they found it. In their paper, published in the journal Tissue Antigens, titled Evidence of an Early European and Amerindian Contribution to the Polynesian Gene Pool, researchers Benedict Alexandra Lai et al. Found large numbers of human leukocyte antigen alleles, again, just genes, that were clearly Native American in origin within their Polynesian samples. And their analysis strongly suggested that these Native American HLA genes entered the population of Easter Island a long time ago, many generations ago. Now, notably, a large limitation of this study was that the researchers couldn't estimate exactly when these American genes made it to Easter Island. They could pretty confidently conclude that they arrived before the mid-1800s, but couldn't be sure of anything beyond that. Thus, there were two possible explanations for the presence of these genetic signals. Quote, "One possibility is that they are the result of visits by crew members of Amerindian descent on some ships arriving on Easter Island after Rohaven, that's the first European to arrive there, but before the early 1800s. Another possibility is that these alleles were introduced much earlier, that is, in prehistoric time by Amerindians. They may have joined Polynesians who made a return voyage from South America, or some Amerindians may have independently reached Easter Island after it was colonized by Polynesians." Unquote. This paper would prove to be the opening shot in what would turn out to be a salvo of genetic evidence for a pre-Columbian contact event. Since 2006, frankly, more research on this topic has been published than we could possibly have the time to cover, even in a video of this scale. But there are two more specific genetic studies that I'd like to share with you, because they indicate a fascinating twist. In 2014, a team of mostly Scandinavian and Californian biologists, led by J. Victor Moreno Mayor, conducted something of a follow-up study to the one done in 2006, which we just discussed. Analyzing many of the same Easter Islander blood samples collected in 1971, but also some new ones, and this time, they weren't just looking for HLA alleles, but a whole plethora of additional genetic markers. Long story short, not only were they able to confirm the results of the 2006 study, finding substantially more evidence of an early Native American contribution to the Easter Islanders' genomes, but by analyzing the size and frequency of the Native American genetic signals they found, Moreno-Mayor et al. Were able to better estimate approximately when said genetic signals showed up in the first place, and thus provide a much more solid date for when this contact would have occurred. Their analysis suggests that it must have happened sometime between 1280 and 1495 AD, or 19 to 23 generations ago, proving that this contact occurred in a pre-European context. Now that a pre-Columbian Native American introgression into Easter Islander genomes had been firmly established, geneticists began turning to other islands across the Polynesian Triangle to search for any evidence of pre-Columbian contact there as well. And what they found was very, very cool. Ladies and gentlemen, allow me to introduce you to what we're going to call the Ioannidis study, one of the most fascinating papers ever published in the journal Nature. Throughout much of 2018 and 2019, a team of researchers operating under the lead of Dr. Alexander G. Ioannidis conducted a genome-wide analysis of over 166 natives from Easter Island, as well as 188 individuals from other Polynesian islands as far west as New Caledonia. Like in the previous study by Moreno-Mayor et al., they were looking for a diverse range of genetic markers associated with Americans, specifically SNPs, but they also had a few years of technological advancement on their side, and obviously a much, much larger data set. Their results would be explosive. Unsurprisingly, Ioannidis et al. Once more confirmed the presence of pre-Columbian genetic signals in Rapa Nui genomes. But they also found these same ancient signals in several additional islands, specifically the Marquesas, the Palisa Islands, and the rather large island of Mangareva. Once more, the researchers were able to roughly date when exactly the genetic signals started to show up where, and this was the real shocker. According to their analysis, Native American ancestry actually arrived on Easter Island kind of late, in approximately 1380 AD, which isn't too far off from what the last study indicated. This ancestry first seems to have shown up on the island of Fatu Iva in the Marquesas around 1150 AD. From there, spreading to the North Marquesas by 1200, and then to Mangareva and the Palisas by 1250. Note that Easter Island generally isn't believed to have been settled by humans until around 1200. Hence, this paper is titled Native American Gene Flow into Polynesia, Predating Easter Island Settlement. The researchers think all of this indigenous American ancestry across Polynesia stems from a single contact event. They think a group of Polynesians and Amerindians met once, had offspring, and then the descendants of that encounter spread the DNA everywhere else. How many people were involved in this initial contact is difficult to estimate. It could have been just a few individuals, or several dozen, depending on how reproductively successful everyone's kids were. Now, looking at a map of the South Pacific, you might notice that the Marquesas, where this Amerindian genetic component first pops up, is like right in the middle of the ocean. It's twice as far from the Americas as Easter Island, more than 4,000 nautical miles away from Peru and Ecuador. So, what's this American DNA doing so far out here so early? Well, to those of you with niche knowledge of how the trade winds work on the Pacific Ocean, this may not sound too crazy. You see, the wind and the currents of the South Pacific Ocean always spin in a sort of counterclockwise gyre. On the south side of the Pacific, the winds blow east, while along the South American coast up to the equator, they blow north. and then along the equator they blow west again. It's thought that voyagers departing somewhere between Peru and Colombia, be they Polynesian ships returning from a voyage to the Americas, or Native American fishermen and trade rafts swept out to sea, could very easily drift their way to the Marquesas within a couple of months, or even much faster if they knew what they were doing. And, as a matter of fact, in their study, Ioannidis et al. Point to a man who proved this. Meet Thor Heyerdahl. Thor Heyerdahl was an eccentric biologist by training who, in the 1940s, after having spent a few years living on Polynesian islands, came to believe that Polynesia was actually first settled by Native Americans who were riding the winds west. He also happened to think that these early Native Americans who made it to Polynesia were fair-skinned and Nordic-looking, or had been taught how to sail and navigate by fair-skinned Nordic-looking people. An idea which was seen as pretty racist and demeaning even by 1940 standards. Whatever the case, whatever Mr. Heyerdahl lacked in racial sensitivity training, he was eager to make up for in experimental voyaging. And in 1947, in an effort to substantiate his theories, he and a group of his Scandinavian buddies, with the help of generous financial support from the United States and Peruvian governments, constructed rafts modeled on what they believed to be indigenous American designs recorded by Spanish chroniclers. A raft which they ultimately named the Kon-Tiki, after a supposed Polynesian sun god. And on April 28, 1947, Thor and his group of lovable Vikings, as well as a pet parrot, set sail on the Kon-Tiki from Peru, eager to catch the westward trade winds and prove that such a Native American craft could make it to the Polynesian islands. And they proved exactly that. After 101 days at sea, Thor and his Scandinavian friends crashed into a reef near the Tuamotus, a chain of dangerous atolls just a couple hundred miles away from the Marquesas. Thor and his friends were able to abandon ship after the crash and make it to a small deserted island, where after a few days they were rescued by a group of confused, but also very generous Polynesian islanders, who took them back to their village, fed them, and kept them safe until a French merchant vessel could ultimately come to their rescue. While their journey ended in a rather rough way, and while nobody takes Thor's wacky ideas about fair-skinned Native Americans seriously, the Kon-Tiki expedition largely succeeded in proving that it was possible, indeed perhaps even likely, that a raft made according to indigenous American standards could simply drift its way into Polynesian territory. And mind you, that's largely what they were doing. Thor and his men simply caught the current and let it take them to the Tuamotus. There was very little navigation necessary on their part. Now, you might say, wait a minute, Nate, how on earth did 5 men feed themselves on a raft for 101 days at sea? Well, it turned out that fishing was super easy for Heyerdahl and his men. In fact, most days, dozens of fish would just jump onto their boat, and rainwater was more than abundant to satisfy their thirst. So they didn't even need very many provisions. In their landmark genetic study, Ioannidis et al. Cite Thor Heyerdahl's expedition as a possible example for how the Marquesas could have ended up with Native American genetic signals. Either Polynesians returning from a voyage that already made it to the Americas could have followed the same winds, or, of course, as Thor suggested, maybe a group of Native Americans could have caught the current. Furthermore, Ioannidis and his co-authors stress that 1150 AD, the year they believe this Native American genetic signal first arrives in Polynesia on the island of Fatu Iva in the Marquesas, is right around the same time that Polynesians are thought to have arrived in Fatu Iva and the Marquesas for themselves for the first time. So, as soon as Polynesians get there, the moment they start settling, they seem to pick up this Amerindian genetic signal. Such a coincidence leads the researchers to make the stunning suggestion that it's possible that when Polynesians first arrived in the Marquesas, there were already Americans living there. Quote, "Our earliest estimated date of contact is 1150 for Fatu Iva, South Marquesas. This is close to the date estimated by radiocarbon dating for settlement of that island group, raising the intriguing possibility that, upon their arrival, Polynesian settlers encountered a small, already established Native American population." Unquote. Now, that's a crazy suggestion, but we're still not done. It gets even crazier. Believe it or not, the Polynesian island where Thor Heyerdahl spent most of his time, and where he ultimately developed most of his theories before the Kon-Tiki expedition, was, coincidentally enough, Fatu Iva. Thor lived on this island for a little over a year in the 1930s with his wife, and he claims that the locals told him that their ancestors first came to the island from the direction of the rising sun, from the east, and that these legends are what inspired Thor's wacky ideas in the first place. Now quoting Ioannidis et al. Once again, quote, "It was on the island of Fatu Iva, the easternmost island in equatorial Polynesia, that Thor Heyerdahl hypothesized that Native American and Polynesian individuals might have contacted one another based on islanders' legends stating that their forefathers had come from the east." Unquote. Now quoting Heyerdahl himself from his book on Fatu Iva, quote, "It was Tiki in the flesh and blood who had led Tai Tetua's ancestors across the ocean to these islands." "From where?" I asked, and was curious to hear the old man's reply. "From Te Fiti, the east," answered the old man, and nodded toward that part of the horizon where the sun rose, the direction in which there was no other land except South America. I was puzzled. Every scientist had taken it for granted that these islanders had come from the very opposite direction, from Asia. But the Marquesans themselves had always alluded to their ancestral fatherland as Te Fiti, literally, the East. Unquote. What a story. When Heyerdahl first made these claims and published these accounts, they weren't taken especially seriously by experts. While his Kon-Tiki expedition was somewhat respectable, it was clear to most scholars that he was a bit goofy, and the underpinning of many of his ideas were very flawed. But fast forward nearly a century later, and modern geneticists are beginning to scratch their heads and speculate aloud. It's important to note that while Ioannidis et al.'s raw analysis of the genomes is solid, nobody disputes that they found these American signals in the Marquesas and Mangareva and the Palisas and whatnot. Their talk about Thor Heyerdahl and possible Native American voyagers from the east beating the Polynesians to the Marquesas is all just speculation. They admit there's just not enough data available right now to draw any conclusions in any direction. Hopefully, in the coming years, more genetic and archaeological studies on islands beyond Rapa Nui can be done, and perhaps we'll gain a much clearer picture. Maybe there's another island out there where these signals appear even earlier. One of the many ways that civilization in the New World diverged from that of the Old was in the New World's absence of an iron smelting industry. You see, Iron exists in nature within a sort of rocky-looking mineral ore known as iron ore. In this rock, this ore, iron atoms are bonded to a large quantity of solid-state oxygen atoms, as well as small amounts of other miscellaneous elements. In this natural form, the ore isn't particularly useful. It's rather brittle and struggles to hold an edge, not to mention all of the oxygen bonds add a huge amount of unnecessary weight. However, when the ore is superheated, usually in something like a blast furnace, past its melting point, the oxygen bonds are broken, and the oxygen is released from the molten mixture. Any other impurities in the molten substance will simply float to the top and can be scraped or chipped away, leaving a blacksmith with the pure, extremely durable, and refined metallic substance that we would all recognize in swords, armors, and tools. Notably, the smoke of the blast furnace would mix a bit with the molten iron during the heating process, leaving behind a small amount of carbon, usually 1 to 3% of the substance's total mass, which actually served to strengthen the final product and create an even more resilient material. This whole process is called smelting, and people have been doing it in the old world since the 2000s BC with clay furnaces. But the techniques and the refined products it produced would not make their way to the Americas until after Columbus's voyages in the 1490s. In certain limited circumstances, Native Americans are known to have acquired iron ore rocks and hammered and polished them into certain useful shapes, but they never took that big step of properly smelting it and converting that iron into the great material it was always destined to be. Which is why a series of discoveries made in the 1970s during an archaeological dig in the Pacific Northwest caused such a stir. On the northwestern edges of the Olympic Peninsula, in what is today Washington State, there exists a particularly significant archaeological site known as Ozette. Ozette was once the home of an indigenous macaw village of great local economic importance, which seems to have been continuously occupied since as early as the 1st century AD, all the way up until the government made everyone leave in the early 1920s, so the kids could attend school. In its heyday, its location made it a premier hub for whale and seal hunting, which dominated its economy and the lives of its ancient inhabitants. While most ancient sites in the Pacific Northwest have, as a rule, preserved poorly due to the moist climate and chilly winters, Ozette is special. You see, sometime in the 1500s, the area was inundated with a major mudslide, which destroyed large parts of the settlement, but also preserved those parts under a massive multi-foot blanket of clay. Excavations at Ozette began in 1966 and lasted up until 1981. They were directed by Washington State University's Dr. Richard Daughtry, who worked hand-in-hand with the modern macaw tribe to meticulously dig up and document more than 55,000 unique artifacts and structural remains. Now, while the Ozette excavation has proved invaluable in furthering our understanding of the ancient macaw peoples and their life in the Pacific Northwest, most of the artifacts weren't a huge surprise or of particular relevance to this video. Lots of baskets, blankets, tons of sea creature bones, the remains of some longhouses. You get the idea. However, one such find, or really, I suppose, one set of finds, proved to be especially stunning to excavators, and relevant to our conversation. You see, within the ruins of 5 separate homes at Ozette, all believed to have been destroyed by that mudslide in the 1500s, excavators found more than 30 clearly smelted iron blades. The blades were extremely small, most being less than a couple of inches in length, and many had been so worn by the elements and time that their purpose is entirely unidentifiable. But most seem to have been used for basic woodworking and perhaps fish filleting. Spectrographic analysis of these blades quickly determined that they had high carbon contents, suggesting that they had been smelted in blast furnaces, and thus must have made it to the Pacific Northwest from somewhere abroad. They could not have been produced here, or, frankly, anywhere else in the Americas at this time. Now, you'll note that these blades were found, again, in an archaeological context dated to sometime around the 1500s. And the 1500s are, of course, well after the arrival of Europeans in the New World. So, couldn't this iron have made its way to Ozette through trade or early explorers? Well, in some theoretical, abstract sense, yes, but probably not. You see, while Columbus may have arrived in the West Indies in 1492, it took centuries for Europeans to fully appreciate and explore the New World earnestly. And the Pacific Northwest was one of the most isolated and last-reached parts of the America by Europeans. The earliest record of Europeans in this region doesn't appear until 1774, with the voyage of a Spanish explorer named Juan José Pérez Hernández. Of course, this doesn't mean that European objects couldn't have made it into the area earlier through indigenous trade networks. European goods often preceded the arrival of Europeans. But Ozette's excavators don't consider that to be a likely explanation either. Not only do the 1500s predate any known arrival of such goods into the region, but if these products were the result of such trade links, then the archaeologists would expect to find other European products at the site, like beads, pots, glassware, and weapons. But they have none of that at Ozette, or even leading into it. So, if these iron blades didn't make their way here through early European contacts, then where did they come from? Well, the site's excavators believe the answer to that question is Asia, likely from damaged Japanese ships that drifted all the way to the Pacific Northwest, as evidenced by bamboo that was found in one of the same homes that iron was recovered in. Now quoting Dr. Paul Gleason, a man who worked on the Ozette site as a graduate student and authored several of the Interim project reports. Quote, numerous metal-bladed tools have been recovered from the pre-Euro-American trade levels at Ozette. Although 28 ferrous-bladed and 14 ferrous-stained tool hafts have been found in levels 4 and 5, no ceramics, beads, or glassware have been recovered from this level. Spectrographic analysis of the testable pieces of metal reveal that they are all high-carbon steel. If the date of 440, give or take 90 years before present, is the general time of the House 1 occupation, then this occupation predates both Russian and Spanish expansion into the region. Iron, however, had been common in Japan since 300 AD. Additionally, the Kuroshiro, or Japanese current, was sweeping materials from Japan to the beaches of Ozette, as evidenced by the 2 pieces of bamboo recovered in the House 1 excavations. There are numerous accounts in North Pacific maritime history of drift junks being sighted near or on the Washington coast. On the North Pacific, there was not only a source, but also a means and an agent for the fairly regular transport of steel and iron to the Ozette area. There have been no comparative studies of the Ozette metal with those of Japan to determine the possible degree of similarities between the two metals. However, personnel who ran the spectrographic tests on the Ozette materials had previously run similar tests on several samurai swords. They noted that there was a close similarity between the trace elemental curves of the Ozette metal and the metal of the swords. This similarity, they felt, would arise from similar smelting processes. Unquote. Thus, the position of Ozette's excavators is that the iron blades they found came from Japan, on ships that were set adrift. When you consider the danger that storms or high winds or high seas pose to shipping vessels, the most immediate thing that comes to mind is that the waves and winds could cause the vessel to capsize and sink. But an equally big danger was that the winds would destroy the ship's mast, that big pole the sail attaches to, as well as the vessel's rudder, which controls steering. If a ship loses its mast and rudder, its crew becomes entirely powerless to control it. It just goes adrift and is totally subject to whatever currents it's riding. And if that were to happen to vessels operating around ancient Japan, the Kuroshiro and North Pacific currents could very easily give it a free, year-long ride to the shores of the Americas. Something to emphasize here is that the winds and currents of the North Pacific tend to spin in a sort of clockwise gyre, starting at the equator up until about 50 degrees north latitude. Once you get towards the Bering Strait, things get a little weird, but that's beside the point. Thus, the currents have created a sort of natural highway running straight from Japan to the Pacific Northwest. Gleason points out that this phenomena of adrift Japanese vessels finding themselves off the American coast was actually something of a regular occurrence throughout the 1800s. In one particularly famous and relevant story, in 1832, a Japanese merchant junk got sucked out to sea by a typhoon, and more than a year and 5,000 miles later, in 1834, it washed up on the shores of Washington's Olympic Peninsula. Only 3 of the original 14-man crew survived the journey, and they were quickly found by the local Makah peoples, who identified the shipwreck and immediately decided to board it and look for useful things. The 3 survivors were actually held as captives by the Makahs for the winter until some American army officers found out what was going on and made the Makahs release the poor sailors, but you get the idea. This whole episode has become known as the story of the 3 Kichis, and in Vancouver, Washington, there is actually a monument to the whole thing. This is just one such example. In his 1985 paper, published in the journal Arctic Anthropology, anthropologist and museum director George I. Quimbley identified records for over 24 North Asian ships that went adrift and found themselves in the Americas between 1780 and 1900. And he insists that there were probably many more such episodes in that period that went undocumented. Thus, scholars in the Pacific Northwest see no reason to doubt that this phenomenon could have been persisting much deeper into history. It's interesting to imagine, that indigenous peoples living in the pre-Columbian Pacific Northwest may very well have occasionally had loot boxes just spawn out of the water filled with legendary, otherwise unobtainable artifacts. How often this was happening if at all, is difficult to ascertain. Gleason clearly thinks that given the sheer quantity of iron artifacts found at Ozette, Japanese drift iron must have been arriving at a very reliable pace. But that's frankly just a guess. Hopefully, in the coming years, more archaeological sites will be excavated, more research will be done, and dissertations authored that can get us closer to the heart of this fascinating, overlooked maritime phenomena and its impacts on everyone involved. Okay, so this next one kind of feels like cheating, because it's really pre-Columbian, but I can't help myself. Here we go. In 1992, work was being done to complete California State Route 54, a highway in San Diego County, now sometimes referred to as the Filipino-American Highway. While construction workers were grading a sound berm, which is essentially a tiny hill often built on the sides of roads near residential areas to help control noise, they stumbled upon what appeared to be very ancient bones. As a result, in accordance with state law, construction work was immediately halted in the area, and a team of paleontologists from the San Diego Natural History Museum, led by Drs. Tom Demaray and the late Richard Cerutti, were called up to lead what was expected to be a rather routine paleontological survey. This is a perfectly normal and rather regular procedure. Whenever construction crews stumble upon old bones or what look like ancient artifacts, they're supposed to halt work and reach out to experts, who are then required to conduct a survey and make sure that any material of note can be excavated and preserved. Both Demaray and Cerutti had been through this process several times before, and had no reason to expect that this time would be a particularly big deal. Alas, they were in for a fun surprise. As survey work began on the site, the team quickly stumbled upon a number of skeletal remains belonging to Ice Age creatures. The bones of a direwolf were found, as well as those of an ancient sloth and an old North American species of horse. All interesting finds, but nothing that the excavators hadn't seen before or weren't prepared to discover. However, midway through their work, Dr. Cerutti and his group of lovable undergrads came across some disarticulated bones of an American mastodon, or Mammut americanum, which was a mammoth-like creature that went extinct around 11,000 years ago. Notably, they did not find a complete mastodon skeleton, just a relatively small handful of bones seen in this diagram. But boy, did these bones tell a story. You see, the paleontologists were quickly convinced that these mastodon remains had been handled by humans. For starters, one of the mastodon's tusks was found standing upright in the soil, penetrating even more ancient soil layers. It looked like a human jammed it into the ground like that on purpose. This isn't something you see often in nature. That's not how gravity tends to work. Furthermore, 2 detached femoral heads were found just lying next to each other. Femoral heads are part of the femur bone, one of the leg bones that lock the femur into the hip socket. Something broke the heads of 2 femurs off from the rest of the bones they were attached to, removed them from the hip sockets, and then placed them next to each other. The rest of the femurs were not found anywhere nearby. You know, mastodon femurs are really, really strong bones. They have to support the weight of a 6-ton organism that walks around and stands up all day. The amount of force that would be necessary to break them like this, and the strange process required for them to end up side by side together, were considered by the researchers to be inexplicable without human intervention. Furthermore, many of the bones at the site featured what Cerutti and Demarais believed to be percussion fractures, i.e., they had been bashed repeatedly with rocks by something trying to crack them, and they could tell that these fractures occurred shortly after the animal passed away, while the bones were still fresh, due to the spiral-like nature in which they occurred, something that only happens when the bone is still relatively fresh. 5 large stones were identified in the area, which the researchers believed were being used as hammer and anvil rocks to break these bones open, and they argue that the surfaces of these stones show evidence of being used in such a way. It's thought that early humans may have been trying to break open these mastodon bones to extract the marrow inside, and perhaps later make tools. To test this theory, Doctors Stephen and Kathleen Holan, yes, they're married, actually visited Africa and used similarly shaped rocks to try to break open the bones of a recently deceased elephant. And they produced extremely similar breakage patterns. Suffice it to say, the folks at the San Diego Natural History Museum were beyond convinced that humans had been messing with this mastodon. And thus, the next step was to date the age of these remains. And this is where things got pretty crazy. According to their 2017 paper, published in the journal Nature, titled "A 130,000-Year-Old Archaeological Site in Southern California," a title which kinda spoils the big surprise, Doctors Steve Holan, Thomas Demarais, and colleagues, including Richard Cerutti, reveal that through using uranium series dating, laboratories have concluded that the Cerutti Mastodon bones are 130,000 years old. Give or take another 9,000 years. This is a stunning revelation on so many levels. Because if these bones were being handled by humans 130,000 years ago, which is exactly what the folks at the San Diego Nat and the authors of this paper insist, then it would change everything we thought we knew about the peopling of the Americas. You know, the academic consensus currently is that humans did not enter the Americas until the sunset of the last ice age, around 14 to 25,000-ish years ago, by migrating across a then exposed land bridge that linked Alaska and Siberia, known as Beringia. It's thought that any time before then would have been too cold, and there would have been way too much ice across Beringia and Canada for people to cross into the continent itself. But any time later than that, and the melted ice would have raised sea levels too high, and Beringia would have been submerged, as it is now. And until very recently, most experts weren't seriously interested in considering any migration that occurred much longer than 16,000 years ago. It's only thanks to a series of modern discoveries that some are now opening up to the idea that these migrations could have occurred in the 20,000s of years ago. But this mastodon site, 130,000 years, that just blows even the wildest, most optimistic, or perhaps insane guesses out of the water. Furthermore, such an early date would necessarily have huge implications for our understanding of human evolution. You see, Homo sapiens, modern humans, what we are, aren't believed to have left Africa until sometime after 90,000 years ago, with most estimates suggesting it was more like 70,000. There are no Homo sapien remains outside of the African subcontinent that we found dated to earlier than that. So, if the Cerutti Mastodon bones were being messed with by human beings 130,000 years ago, as the researchers believe, then it could not have been modern humans doing it. It must have been some lost, yet unknown lineage of ancient man. While modern humans didn't leave Africa until 90,000-ish years ago at the earliest, Homo erectus, a more archaic, primitive species of hominid, had started leaving Africa almost 2 million years ago, and a bunch of new human species came from them after they left, like Neanderthals, Denisovans, and the like, which were then overrun and, to an extent, interbred with by modern humans when we left Africa. So, in theory, it's possible that some human lineage could have made it to Southern California that's probably now a lost species. And that is exactly what Desmarais, Cerutti, and the San Diego Nat and Holin et al. All believe happened. They think that a yet unknown ancient lineage of man, descendant of Homo erectus, found its way into the Americas, and that they were responsible for the creation of this mastodon site. I personally was so blown away by this story that I actually recently traveled to San Diego, California, and visited the Natural History Museum to see the bones for myself. And boy, was it an experience, and are they proud of this. The first thing you see when you walk into the San Diego Nat through its main entrance is this enormous center stage exhibit they've created displaying the Cerutti Mastodon bones, and what they claim were the hammer and anvil stones. The exhibit, in no uncertain terms, declares that the Cerutti Mastodon proves ancient humans were in America 130,000 years ago. Much of the B-roll for this section was shot on my iPhone during my time at this exhibit, so that's why some of the footage on screen is probably a little lower quality than what you're used to, but it's all here. Here's the tusk, the femur heads I mentioned, the hammer and anvil stones, and a bunch of other bones and rocks which they argue show clear signs of percussion fracturing. So, there you go. In 1995, paleontologists at the San Diego Nat excavated mastodon bones with what they claimed to be was clear evidence of human handling. And when dating technology caught up, they were eventually able to date the bones to 130,000 years ago, proving that humanity had made it into the Americas far earlier than anyone ever thought possible. Case closed, right? Well, not exactly. As you might imagine, despite the incredible confidence of the San Diego Nat in their findings, their conclusions have been challenged by a number of experts, and almost as soon as their landmark 2017 paper dropped, much of the academic community fired back with skepticism. Dr. David J. Metzer, an archaeologist at Southern Methodist University, known for his work on Paleo-Indians and the peopling of the Americas, said this in response to the study when speaking with the Scientific American magazine. Quote, "You can't push human antiquity in the New World back 100,000 years based on evidence as inherently ambiguous as broken bones and nondescript stones. Not when they are coming from a highway salvage excavation done 25 years ago, and you have none of the detailed taphonomic evidence demanded of such a grandiose claim." Unquote. While pretty fiery, I think this is a very sensible response. If humans really were in the Americas 130,000 years ago, why is our only evidence these bones dug up off of California State Route 54 that aren't even human bones? They're mastodon bones that might have been handled by people. I mean, sure, it's not like archaeologists and historians have been running around looking for evidence of such an ancient human population in the Americas, but even still, major construction projects like State Route 54 have been going on in the Americas non-stop for centuries, and thousands of salvage excavations have been performed by experts. You'd think if there really was a population of humans running around way back then, we would have found some additional evidence of that. And as Metzer points out, what we'd really need to prove such a dramatic claim are the actual remains, the taphonomic evidence of those humans. If we could find some datable human bones from that time, then maybe we'd be in for a paradigm shift. But until that happens, this is all just controversial speculation. Shortly after the landmark 2017 Mastodon paper was published, Dr. Metzer went on to co-author a response paper of his own, alongside Dr. T.J. Brage et al., rhetorically titled, "Were Hominins in California 130,000 years ago?" In which the authors point out that just because the folks at the San Diego Nat were able to prove that humans could have tampered with the Cerutti Mastodon site, doesn't at all prove that humans did tamper with it. Quote, Holin et al. Claim to present multiple lines of evidence establishing a hominin presence in California 130,000 KYA, but their conclusions are based primarily on a series of modern experiments suggesting that humans could have fractured mastodon bones and teeth, producing fractures and striations consistent with those identified on bones and cobbles recovered at the mastodon site. They offer no alternative hypothesis that fully assess the role of natural taphonomic processes in producing those same products. Instead, their analysis is a classic illustration of the fallacy of affirming the consequent. Just because humans could have fractured the Cerutti Mastodon location remains does not mean they did fracture them. Unquote. In response to this criticism, Holland and the folks at the San Diego Nat actually published their reply to this reply in the journal Paleo America, arguing that Metzer and Brage et al. Misrepresented their arguments, and insisting that they did actually consider multiple alternative hypotheses behind the strange condition of the bones, and adequately ruled each one out using the scientific method. They go on to explain that no, the specific nature of the percussion fractures and damage to the hammer and anvil stones is clear evidence of human interaction and couldn't have been produced any other way. This response paper is hilariously catty and was hard for me to read without cracking up a few times. Whatever the case, other experts have raised concerns about the context in which the Cerutti Mastodon bones were found, and specifically question whether the construction work taking place nearby and on top of them before they were discovered could have been a factor in many of the anomalies Holin et al. Blame on humans. In 2019, Patrick M. Farrell, a former California Department of Transportation land surveyor, published a paper in the journal Paleo America, arguing that the rocks Holin et al. Claim were hammer and anvil stones may have simply been raked into the site by a caterpillar excavator, and that much of the damage done to the bones could have been a consequence of the enormous weight of the machinery that was driving all over the site prior to its excavation. Farrell and Brage and Metzer et al.'s papers were just some of the skeptical responses to the Cerutti Mastodon paper, and frankly, there were more than I could feasibly cover in this video. These two just represented what I think were some of the most salient arguments. However, I would be remiss if I didn't mention one last study. In December of 2021, Luck Boards and colleagues, including Tom Demaray, conducted a follow-up study on the supposed hammer and anvil stones found at the site, and they claim to have found micro-residue from the mastodon bones on these rocks, dispersed in a pattern consistent with these stones being used as hammers and anvils, which they argue validates the San Diego Nat's original findings and rebukes many of their critics. Suffice it to say, the debate around the Cerutti Mastodon site remains ongoing. There are so many more papers representing both perspectives that I didn't have time to cover, and there are certainly even more being produced as we speak. Whether or not this mastodon proves that humans were in North America 130,000 years ago is an argument that will likely go on for years to come. And all I can say is that there are some very accomplished, respectable experts much smarter than myself representing each perspective. But nothing approaching a consensus appears to have been firmly established just yet. And with that, ladies and gentlemen, we are going to wrap up. Roughly an hour and 40 or 50 some minutes of pre-Columbian contact, theories and papers, I suppose. I hope you all enjoyed. I know this video took a little while to get out, but I had a blast making it, and am pretty proud of the final product put together. You know, when you try to search for pre-Columbian contact theories or evidence, results are often filled with some really fun, but often not especially academically robust results. You get a bunch of stuff about Atlantis and Lemuria and whatnot, but if you're willing to open up your wallets to the academic journals, you'll find that there's a pretty large corpus of research behind this subject, and a lot of serious experts are more than open to the idea of some sort of pre-Columbian exchange, however small that exchange may have been. Personally, through my own research in this video, and just years of doing my own reading, I've become rather convinced that there were limited and sporadic exchanges of goods and peoples between the two hemispheres going back deep in time. I mean, what we already now know about the Polynesians and, of course, the Vikings proves this outright, but humans are just such a curious, intelligent, and daring species that my suspicion is there are some even more, yet unconfirmed, examples. There's this expression that I've constantly heard throughout my life, that we're born too late to explore the world, yet too early to explore the stars. Which, first of all, I think we're right about at the beginning of space exploration, so that's moot, but even more so, advances made in LiDAR, and especially genetics, both human and non-human, are going to revolutionize our understanding of the past, and perhaps our understanding of just how connected the two hemispheres were in the days before Columbus. Anyway, thanks for stopping by, everyone. A robust bibliography with all of our sources is in the description, though many of the journals are paywalled if you don't have the right .edu credentials. Sorry this video took so long getting out. I know it's been like 3 months since my last upload, which is way too long, I know. Part of the reason is that I was working on another historical mysteries video and got halfway done with that one before I went down this rabbit hole about custard apples, and the meaning of their Indian antiquity got me sucked into this new project. But that means the next video, which is already half done, should be out much sooner. Hopefully well before the end of the month. And I hope to see you there. And of course, shout out to War Thunder again for sponsoring today's video. Make sure you check the game out now for free on PC, PlayStation, Xbox, or mobile using my links in the pinned comment or video description. Those of you who are new or haven't played in the last 6 months will also receive a massive bonus pack across PC or console, including multiple premium vehicles, in-game currency, and more. Thanks for watching, everyone. Peace out, everybody.